Hello, in today's video we are going to be looking at how to find the area of different shapes. We're going to first start by finding the area of our trapezoid, which is on our coordinate grid. Find the area of the shape by breaking it down into triangles and rectangles. So what if we forget our trapezoid formula? How can we do it without that formula? Well, what we can do is we can break shapes like the trapezoid or a shape that doesn't have a name into shapes that we do know. So I could take this, and if I drew a line right here and drew a line right here, I've now broken it down into two triangles and a trapezoid. That's a horizontal and a vertical line forming those right triangles, and that's how I know where my base and where my height is, because the base and the height are always perpendicular to each other. I have a horizontal line, so I can count that this length is 2. I can count up 1, 2, 3, 4, 5, 6, 7. The height is 7. My triangle over here, that's also a 2 and a 7. In the middle I have this rectangle. The height of the rectangle is 7. The width is 1, 2, 3, 4. So we can break this down into a rectangle. So if I have the area of a rectangle, we know this one. That's just going to be base times height. And the base is 4 times the height of 7. It doesn't matter which one you say is the base and which one is the height. And area is squared. We don't know if it is an inch or a meter or whatever, so we're just going to say units squared. Then we have a triangle. The area of a triangle is 1/2 base times height. And the base and the height are always perpendicular, so it's 1/2 the base of 2. The height of 7. 1/2 of 2 is 1. 1 times 7 is 7 units squared. But we have 2 of those triangles. So when I find the area of this trapezoid, we have the rectangle, which is 28, plus one triangle of 7, plus a second triangle of 7. So the area of our shape is going to be 42 units squared. All right, so that's one way that we can approach any of our shapes. We can break them down into shapes that we are familiar with or shapes that we remember the formulas for. When we get into the rest of our problems, we're going to use the formulas on our formula sheet. So we want to first look at it and figure out what shape is it. So when I look at our first one, I can see that this is going to be a triangle. And because I know it's a triangle, I'm going to look and I'm going to find my triangle formula, which is 1/2 base times height. So first identify the shape. Second, find the appropriate and correct formula that corresponds to that shape. Now we want to find the area of the shape, give exact answers, and you can use your formulas. So we see here, the one thing that's really important to remember is what is the B, what is the H? The B is the length of the base. The H is the length of the height. And the one thing that we always know is that the base and the height are perpendicular to each other. So when I see that right angle, I know that the base is going to be that entire bottom. And so when we look at that, this base is going to be 16. So the area formula is 1/2 the base of 16 times the height of 8. So the area of our triangle is 64, we look at our label, feet squared. See, not too bad. We go to our next shape, we look at the shape, and it should sound familiar, look familiar, because we had one above. This is going to be a trapezoid. We're not going to break this trapezoid down into smaller shapes. We're going to use our trapezoid formula. So we look at our formula sheet, we look at all of the options, we identify the correct formula that's going to go with our trapezoid, and that is 1/2 height times base 1 plus base 2. Again, when we see the formula, you have to know what each of these letters are representing for that diagram. The H is the height, and the height of our trapezoid, just like the height of a triangle, is going to be the length that is going to be perpendicular to the base. The trapezoid has two bases, we have our base on top of 7 millimeters and our base on the bottom, which is 15. So when we go to plug these numbers into our formula, 1/2 the height of our trapezoid, which is 12. The bases, we have two bases of 7 and 15. We want to be careful with our order of operations. We've got parentheses over here telling me to add the 7 and the 15 first. So 1/2 of 12, 7 plus 15 is 22. You could simplify this. Half of 12 is 6, and then 6 times 22, or you can just go straight to your calculator. And you can type in 1/2 times 12 times 22, and we find that the area of this trapezoid is 132 millimeters squared, making sure that we always have our label on our answer. Our next shape, as we look at this, we all know that this is going to be a circle. If you have to look at your formula sheet, go ahead. Otherwise, we just finished up a unit on circles. We know that the area of the circle is pi r squared. The only thing that we have to find here to find the area is that r. Remember that the r is representing the radius of your circle. When I look at my diagram, I just had that 18 across, which means that that 18 is the diameter, and 9 is going to be your radius. So be very careful about using the correct value. So pi times our radius of 9 squared, giving us the area of our circle as 81 pi millimeters squared. Our last one, and this one, as we look at our shape, is going to be a kite. We remember from our quadrilateral unit that our kite, we have those two consecutive sets of congruent sides. And with kites, we know that our diagonals are perpendicular, and the short diagonal is being bisected. So just some knowledge that we have to remember. Because this is a kite, we look through our formula sheet and we see that the area formula for a kite is going to be 1/2 times diagonal 1 times diagonal 2. So there's two things I need to find here. I need to find the length of this diagonal, which I don't currently know, and we need to find the length of this diagonal, which I also don't know. So we've got a lot of work that we've got to do here. First thing that I notice is this 45-degree angle, and this is a right angle. This is going to make a special rights triangle, and our pattern for a 45, 45, 90 is S, S, S root 2. So following that pattern, we have the hypotenuse, which is S root 2 equal to 12 root 2. That tells me that my S is going to be equal to 12. So this side is 12, this side is 12. These two sides are congruent, remember, so this is going to be 12 as well because that short diagonal is being bisected. That's going to actually give us our first diagonal. So we have 1/2, that short diagonal is 24, 12 plus 12. On our long diagonal, we do have that this portion is 12. We need to find this part right here. Now that I have this right angle and two of my three sides, to find that missing length, we can do Pythagorean Theorem. Leg squared plus that unknown leg squared is equal to the hypotenuse squared. So we've got 144 plus x squared equals 1369. We move that 144 over to get 1225. We square root, and x is equal to 35. So to find the length of this entire diagonal, our diagonal 2, we have to add that 12 and the 35 together to get 47. So there's our second diagonal of 47. Again, we can just go straight to our calculator. 1/2 times 24 times 47. And the area of our kite is going to be equal to 564 inches squared. As we go to do our areas, remember it's important to first identify the shape, second find the appropriate formula, and then make sure that you correctly identify what each of the letters are standing for and find or calculate those based on your diagram. All right, that's it.